Okay, let's implement this part together. The first thing is we need to calculate the gradient using our numerical gradient function. And we need to pass our function f and current value x. And what we do after we calculate gradient is updating this x with learning rate with the amount of gradient. That's all, pretty simple. That's our gradient descent. Let's check how our gradient descent is working through this example. This is the same function as before. Let's say the initial x value starts from minus 3.0 and 4.0. And let's set learning rate and step number as 0.1 and 20. And let's get x and x history from our gradient descent. We're going to pass our example function and init x, learning this as our learning rate, and step number as the step number we defined, like this. Let's plot this one. So the plotting region is going to be from -5 to 5. Zero comma 0, -5 to 5, like this. And we're going to, so this is some lines to distinguish our plot. And we're going to plot x history, first component, and x history, second component. And we're going to use O and set the y limit and x limit minus 3.5 and 3.5. And y limit is minus 4.5 and 4.5. X label as 0. Y label as x1. Let's plot this one. This shows that starting from minus 3.4, it correctly finds where to go to reach the minimum. The minimum is achieved at 0.0, the origin. So we can say that our gradient descent is working perfectly. However, let's inspect this a little deeper. What if we use a huge learning rate, like 10.0? What would happen? The thing is, let's remove this limit here and here. Then it goes here and there. So if we set our learning rate as 10, it does not reach the minimum. And let's see another example. And at this point, what if we set our learning rate as 10 to the minus 5? What would happen? Then it barely moves. It just stays here. And when we zoom into this region by removing this limit, it moves a little bit. However, it's hard to see where it's going. It barely moves. So it is actually updating. However, it minimally moves. So it's moving. However, it's not noticeable. So from these two examples, we can recognize that we need to set proper learning rate or step size. That is why researchers are working on this problem. Okay, that was about calculating gradients.